Okay, let's get into this. We are doing a deep dive today into a story about a medical pioneer whose work, and this is no exaggeration, was a literal life-changing shortcut for thousands and thousands of children.
Hmm.
And it's not just a story about a discovery, it's really about uh, a stubborn refusal to accept scientific despair. It's about a chemist using pretty basic tools to overturn some really entrenched medical dogma.
It's a fantastic story.
Our focus is on Louis Isaac Woolf. He was a British biochemist who lived from 1919 all the way to 2021. I mean, just an incredible lifespan. And he's really one of the quiet giants behind one of the greatest successes in preventative medicine.
He really is.
Yeah.
And our mission today is to unpack that journey he took from being this, dedicated researcher in London to becoming this major international figure in public health.
Right.
We want to understand the specific technical innovation and then the incredible advocacy that made early detection and crucially the effective treatment of phenylketonuria, or PKU, the standard that it is today.
He didn't just find a treatment, he changed the whole approach.
He really did. He changed how we think about inherited metabolic conditions entirely.
So to really get the scale of that achievement, we have to start with the man himself. Louis Isaac Woolf, born April 24th, 1919 in Hackney, London. His family was Romanian Jewish.
And he clearly had this affinity for the hard sciences from early on. He earned his PhD in chemistry from University College London, UCL, back in 1945.
And his career path, it put him right at the cutting edge of pediatric medicine almost immediately.
Yeah, in 1947, he got an Imperial Chemical Industries Research Fellowship, and it was at one of the world's most famous children's hospitals, Great Ormond Street in London.
And his focus was very specific.
Very. He wasn't just doing general chemistry. He was zoned in on how the body handles amino acids, starting with tyrosine metabolism in premature babies.
And that specific focus on amino acid metabolism, that's what funneled him right toward what was, at the time, this devastating challenge, phenylketonuria, PKU.
And this is where we really need to understand the stakes. When Woolf started his work, PKU was, for all intents and purposes, a tragic and irreversible diagnosis.
What exactly is it?
It's a genetic condition discovered in the 1930s where the body just can't break down an amino acid called phenylalanine. And when that builds up, it's incredibly toxic to a developing brain.
So the outcome for a child with undiagnosed PKU was a severe intellectual disability.
Yes. And the scientific consensus at the time, it was crystal clear. PKU is untreatable. It's genetic, therefore it's inevitable. That was the thinking.
You're just managing a tragic outcome.
It was an impasse, really. The idea of a dietary intervention, limiting phenylalanine, that had been floating around since the 30s.
So people had the idea.
They had the idea, but the difficulty was all technical. Phenylalanine is in almost all proteins. So to treat it, you'd need a diet so low in that one specific amino acid. Well, it was basically impossible to create a diet that was also nourishing enough for a growing child.
So the goal was simple to state, just restrict the phenylalanine, but the execution was, next to impossible.
Exactly. It sounds like the research community had just hit a wall. They knew the cause, but they couldn't deliver a solution.
But Woolf didn't buy that. He didn't accept that impossibility. He held this really bold conviction that if you could just manage the intake, PKU could be treated through diet.
And that's the moment, right? That's where you see the determination of one researcher taking on the entire medical establishment.
Which brings us to the technical breakthrough, because this is the specific innovation that really enabled the whole revolution.
It is. The challenge was all about filtration. How do you practically and safely separate out that one amino acid derivative?
And the breakthrough that Woolf delivered was, well, it sounds almost deceptively simple.
Incredibly effective, though. He pioneered using activated charcoal to filter phenylalanine from something called casein hydrolysate.
Okay, let's pause there because that's the key. What is casein hydrolysate and why activated charcoal? Is that like what we have in our water pitchers today?
That's a perfect analogy, precisely. Casein hydrolysate is just milk protein that's partially broken down so it's easier to absorb. It's a base for medical diets.
Okay.
The problem, again, was the phenylalanine in it. So Woolf used activated charcoal, which is essentially a chemical sponge. It has this huge surface area, and it's great at binding to organic compounds.
Oh, it just pulls it out.
It pulls the large, cumbersome phenylalanine molecules right out of the liquid mixture. It's a really elegant piece of applied biochemistry. And that purification method was the critical groundwork. Without it, the diet was just a theory.
That's incredible. It just solves the technical problem almost overnight. And now that they had a safe protein source, they could finally test the hypothesis.
Absolutely. The lab finding moved straight to the clinic. In 1951, Wolf collaborated with a key teen pediatrician Horst Bickel, John W. Gerard, and they conducted the very first successful clinical trial of this new diet.
And we really have to stress the environment they were in. Our sources say the atmosphere was one of, skepticism and professional challenges.
Oh, massive skepticism. They were treating a young PKU patient, and if this diet failed, they risked huge professional criticism for, wasting time on a hopeless genetic case.
They were challenging the professional despair itself.
Exactly. And when you look at medical history, these moments of defiance, they're rare. And the stakes for the patient and for the field were just monumentally high.
So the result of that trial, this was the aha moment.
It was the moment that changed everything. The patient on the diet showed significant clinical improvement.
Wow.
And that single finding just overturned decades of accepted wisdom. It proved the condition was treatable if you could manage the toxicity through diet. PKU is no longer a life sentence.
So that success completely shifts the landscape. They have a treatment that works, but now they're facing the next huge problem. You have to catch it
early as possible.
Yeah.
Before any brain damage happens.
Yeah.
Treatment without early diagnosis is, well, it's useless. So Wolf's work pivots. It goes from treating the individual to figuring out how to protect the entire population. They needed a fast, universal method for early diagnosis.
Which leads us to his next huge contribution. In 1957, just 6 years after that trial, Wolf and his colleagues recommend implementing mass screening for PKU in all newborns.
And they needed a test that was simple, cheap, and easy. The method they proposed was the ferric chloride test, done on a urine sample.
So how did that actually work? Was it complex?
No, and that's the genius of it. It was a visual chemical indicator. If the baby has high levels of phenylalanine, it spills over into the urine. You add a drop of ferric chloride. If the urine turns a bright green color,
You've got a positive result, an immediate visible flag for PKU.
Exactly. And that simplicity was essential for it to be adopted widely. Plus, they were so specific about the timing, they proposed screening at 21 days after birth.
Why 3 weeks?
It was the sweet spot, enough time for phenylalanine to build up to detectable levels, but crucially, before any irreversible cognitive damage set in.
And this simple urine test, it just takes off. It becomes the basis for the first commercial PKU screening test, Phenistix, which came out the very next year.
The commercialization was huge. It meant every local clinic, every pediatrician could do the test without any special equipment.
And the adoption timeline is it's staggering.
It is. Phenistix and mass screening programs were adopted rapidly in the UK, then the United States, and then globally.
Yep.
It became standard preventative care almost overnight.
Yeah, our sources even track specific pilot programs, like one in Granada, Spain, from 1966 to 67. Within a decade, this approach was being used across continents.
It's just a perfect example of a low-cost, high-impact intervention that prevents lifelong disability. I mean, every newborn screening test you see today, that heel prick test, that screens for dozens of disorders.
Yeah, it all comes from this.
It's all conceptually founded on Wolf's realization that early intervention is possible, essential, and scalable.
It's an amazing journey, from a chemical filtration method to a global public health strategy. But Wolf's career was nowhere near finished. In 1968, he moves to North America.
Right. He joins the faculty at the University of British Columbia, UBC, in Vancouver.
And his focus broadens even further.
It does, which is fascinating. He obviously stayed involved with PKU, but his expertise expanded to a whole wide range of inborn errors of metabolism. He really became a foundational figure in that entire subspecialty.
He didn't just rest on his laurels. He kept refining the understanding of PKU itself right into the late 70s.
That's right. As late as 1979, our sources show he was publishing on the complex variants of PKU. He was pointing out that not all patients are the same, that some have phenylalanine levels below what was considered the typical PKU threshold.
He was just constantly sharpening the diagnostic picture.
Exactly. Making sure treatment was tailored and appropriate for every single child, because these disorders don't always follow the textbook.
That dedication is just extraordinary. He retired in 1984 as professor emeritus at UBC and lived until 2021. He was 101 years old.
A whole century of scientific change. And when you distill it down, his career really has these two towering achievements, right?
The treatment and the screening.
Establishing the first effective treatment with his activated charcoal innovation, and then designing the first widely adopted neonatal screening protocol. He is the ultimate example of a determined chemist who literally saved minds.
And the insight from that for you, the listener, is just so profound, proving you can proactively treat a genetic condition before symptoms appear. That's the cornerstone of so much of modern pediatric care.
It's a shortcut to wellness for countless families who might have faced an unthinkable tragedy. And that impact continues today with every standard newborn screening program across the world.
But to leave you with a final thought to mull over, even after all that success, Wolf kept investigating the complexity of lifelong management. He specifically looked into the consequences of interrupting a low-phenylalanine diet in later childhood.
And that raises a really important question for you to think about, one about compliance and long-term care. If a condition is managed successfully from birth with a strict diet, what happens cognitively, behaviorally? What happens if that strict compliance eases up during, say, the turbulent teenage years?
It's a powerful reminder.
It is. It reminds us that while early intervention is a miracle, managing these inherited disorders is often a profound, lifelong commitment.